Hello children and welcome to the session today. Children, in the series of reactions that we have been learning over the last two chapters, let us continue learning a few more. So we have learnt about different substances. We've learnt about acids, bases and salts. We have learned what happens when acids and bases are mixed together. So what happens? A new substance is formed. So what is that? A change. A change occurs. Similarly, children, changes occur all around us at all points in time. And you know what? All these changes are either reversible or they are irreversible. How? We are going to study in today's session in chapter number 7, Physical and Chemical Changes. So we are going to learn about what a physical and chemical change is, what are the characteristics of chemical reactions, how many type of chemical reactions there are, and how can we separate a solid from a solution. Now let's quickly watch a video to understand what physical changes are. Many changes keep accruing around us. Changes can be classified as physical change and chemical changes. A physical change is one in which only physical properties like shape, size, color and state of a substance get changed and no new substances are formed. Take a piece of chalk and crush it. Add a little water to the chalk dust to make a paste. Roll this paste to make a piece of chalk and leave it to dry. You could recover the chalk from chalk dust. Take a few ice cubes in a tray. Leave it in the sun. The ice melts. Place this melted ice water in a freezer. Ice is formed. No new substance is formed during the melting of ice and freezing of water. Only a change of state takes place. So we have understood that a physical change can be reversed. Now let us understand about chemical changes. So a chemical change is a change in which a new substance is formed. How is that? Now if you take the example of rusting of iron, it is a chemical change. How? Let us again watch a video to understand the same. If you place a few shiny iron nails in a plate in the open for a few days, when the weather is humid, the shiny nails will acquire a brownish substance on them. This substance is called rust and the process is called rusting. Most iron articles left in the open rust when they come in contact with air and moisture. Remember, rust is not the same as iron. So children, now you understand what is rusting. So rusting is a very damaging process that ruins our gates. It ruins so many things that are made up of iron around us, and even big things, huge things like ship which are constantly in contact with water, they are also affected a lot by rusting. How do you prevent rusting? Number one, you paint the surface with paints like red oxide. You apply oil and grease on the exposed surface. This removes the contact with air. Then galvanization. So when you coat a piece of iron with another non-reactive metal, it is known as galvanization. Covering the exposed surface of iron with relatively less material by the process of electroplating. So electroplating is similar to galvanization. Galvanization is specifically deposition of zinc over iron, whereas electroplating will be covering with a less reactive metal. Now children, what are the characteristics of a chemical reaction? So when a chemical reaction takes place, number one, there is evolution of gas. Number two, there is change of color. Number three, there is formation of precipitate. There is a change of state, and there is evolution and absorption of heat. So either of the two can take place. When there is evolution of heat, that means heat is given out. It is known as an exothermic reaction. Heat is given out. And when the heat is absorbed, it is taken in. It becomes an endothermic reaction. Now let us understand these points one by one. So we will take up equations to understand these processes. Let us understand the evolution of gas with this example. When zinc reacts with dilute hydrochloric acid, zinc chloride is released with hydrogen gas. When iron sulfide reacts with dilute sulfuric acid, hydrogen sulfide gas and ferrous sulfate are produced. Change of color. If you add copper sulfate, which is blue in color, in water, it gives anhydrous copper sulfate that becomes white in color and water. When manganese dioxide reacts with hydrochloric acid, manganese chloride, water, and a greenish yellow color chlorine gas is evolved. Some chemical reactions result in the formation of an insoluble substance called precipitate. Let us take the example of barium chloride, which reacts with sulfuric acid to give barium sulfate and hydrochloric acid. Barium sulfate is an insoluble precipitate. Similarly, when ferric chloride reacts with sodium hydroxide, precipitate of iron oxide is formed along with sodium chloride. Some reactions also lead to a change of state of the combining elements. When hydrogen gas reacts with oxygen gas, it forms water, which is liquid in state. When ammonium gas reacts with hydrogen chloride gas, ammonium chloride is formed, which is a solid. So children, we have taken the example of different reactions to understand what happens during different chemical changes. Now let us understand another example of decomposition reaction. So what do you mean by decomposition? Decomposition means when a substance is broken into smaller pieces. So let's take the example of the first reaction, calcium carbonate. So calcium carbonate is a compound which is broken down into calcium oxide and CO2. So it is breaking down into two. So what is this? A decomposition reaction. Similarly, potassium chlorate breaks down into potassium chloride and oxygen. So what does this again show us? It shows us decomposition reaction. Another reaction which is very interesting is known as a single displacement reaction, and in the same category also comes a double displacement reaction. So what is going to be displacement? Displacement means when something is moved from its original position to a new position. Now how do these two reactions take place and what are the examples? Let us understand that now. When blue color copper sulfate reacts with iron, it leads to the formation of ferrous sulfate and copper is displaced from this reaction. This is a single displacement reaction because only one substance or one element is being replaced from its original position. Taking the example of lead acetate, when it reacts with hydrogen sulfide, it forms acetic acid and lead sulfide. Again in this reaction, we see that only one element is replaced or displaced from its original position. This reaction shows us a double displacement reaction. Copper chloride reacts with sodium carbonate. The products are copper carbonate and sodium chloride. As is clear, both the elements are displaced from their original position. Therefore, this is a double displacement reaction. In the reaction of magnesium chloride and silver nitrate, the resultant products are silver chloride and magnesium nitrate. As is evident again, both magnesium and silver combined with a different set of substances to form new products. Now let us understand precipitation reactions. As we have studied earlier, in precipitation reaction, as example of barium chloride plus sodium sulfate, it leads to barium sulfate. Now this is a precipitate which is written as PPT in short. This is insoluble in water. Similarly, when lead nitrate combines with hydrochloric acid, it gives us lead chloride, which is again a precipitate. Now children, the next series of reactions is known as neutralization reactions. In neutralization reactions, we've already studied in the previous chapter that acids combine with bases to form salt. And in this reaction, if the acid and base are equal in strength, a neutral substance will be formed, which is known as a salt. Let us understand some examples from the book. So here H2SO4 combines with KOH. It gives K2SO4, H2O and E. E means energy. So this reaction gives out energy. Now take the example of HCl, NaOH. When they combine together, they form NaCl, which is a salt, and they give out water. So these are neutralization reactions. There are some reactions which are known as oxidation reactions, and there are other reactions which are known as reduction reactions. How are they different? Let us understand again with the help of equations given in your book. Now, if you take these two examples, in both these examples, oxygen is being added. In the first case, it is forming magnesium oxide. In the second case, it is forming aluminum oxide. These reactions involve addition of oxygen. Therefore, these reactions are called addition or oxidation reactions. Taking this example of the given reaction, Fe2O3 plus 3H2 gives 3H2O plus 2Fe. In this reaction, hydrogen is being added and oxygen is being removed. So this kind of a reaction is known as a reduction reaction. And the substance which provides hydrogen to the other substance or removes oxygen from the other substance is known as a reducing agent. So now children, having studied the different kinds of reactions, let us understand how a solid is separated from a solution. So the first and the most common example is evaporation. So when anything is mixed in water, what do? You begin to heat the solution. And when you heat the solution, what do you get? You get the substance at the bottom of the beaker and all the water is evaporated. Another example is crystallization reaction. In crystallization reaction, the crystals of the substance that we need are formed. Let us understand with this activity given in your book. The activity tells us how to create crystals of copper sulfate in a laboratory. In order to obtain crystals of copper sulfate, the concentrated aqueous solution of copper sulfate is allowed to evaporate below the boiling point of water. Soon all the water is evaporated, leaving behind blue shiny crystals of copper sulfate. In order to grow a crystal, a small amount of crystalline substance, of which a giant crystal has to be obtained, is lowered in the solution containing one of its state. Soon the constituent particles of the crystal deposits over the lowered particle and a giant crystal is obtained. So in the first image, we can see how copper sulfate solution is being heated, and in the second picture, we can see how copper sulfate crystals are formed. So children, in this chapter, you have learned the different types of reactions. You've also understood what happens in these different type of reactions, what kind of products are formed, what are chemical changes, what are physical changes. So I hope you have understood the chapter very thoroughly and you're ready to attempt the questions at the back. Thank you for joining us.